So CQRS and event sourcing will be then. Okay. So I think I'm kind of a new bloke for you. So who am I? I'm this guy. Okay, the one who just tried to write as much code as he can. Okay. I have been an MVP since 2003. I'm a regional director at Magnus, and I'm co-author of a book some of you might have read, and I'm co-founder of the longest established .NET user group in Italy. We founded it in 2001, actually, July, but I just tried to get rid of everything to be able to write code, okay? And today we will talk about three things, actually, 3 points. So CQRS, yes, recap. Raise your hand if you're already acquainted with CQRS, just to, okay? And raise your hand if you're already acquainted with event sourcing as a persistent strategy. Okay, thank you. And we're going to have kind of a recap in order to level, okay, our acquaintance with these concepts. And then we'll talk about how we can take advantage of Azure, of the Azure platform, both as an infrastructure as a service, but as a PaaS provider as well. How can we deploy such an architecture, a solution? And then we talk about technology and some economic consideration, because I don't know whether you read the talk summary, but in the summary I talked about costs. Okay, so how to deploy such an infrastructure without having our costs soaring, the prices soaring. Okay, going sky high. And obviously, we are not going to talk about the very way to implement CQRS and event sourcing. Still, we're going to talk about working a feasible, viable way, the way we are following, the path we are following to actually develop a real product, SaaS product, which we sell in Italy, okay? But a stripped down version of the product is available on GitHub, and so the code we're going to look at is available for download on GitHub under the AGPL v3, so the Afro GPL v3 license, okay? So just click on the hyperlink and have a look at it. Okay, and we start looking at a picture, a still frame, actually, okay? And if we were to get the gist of this picture, of this frame, without having read the Lord of the Rings trilogy, or without having watched the movies, the films, okay, we could actually think that what we're looking at is a picture of a few fancy dressed guys who are blokes who are going on a jaunt, okay? So they have a boat waiting for them, and we're having a jaunt. And reality is that the hobbits are taking the Elvis to the boat that will take them to the place where they are to die, to pass away, okay? Because elves do die. They don't die in front of ordinary people, okay? Unless they are slashed by a sword, okay? And if I were in the elf, I'd prefer being on a jaunt rather than having to pass, okay? And that's the point. That's the mistake we could incur in, we can make if we have to infer, okay, a meaning only having a look, only being capable to have a look at a still frame, okay? But if we were given the chance to know what's happening a long time, okay, we couldn't make such a mistake. This means if we could have a look at the events, of the occurring events, we could very well understand the meaning, the very meaning of the still frame, okay? And that's it. That's what event sourcing is all about, okay? Event sourcing is all about using events as our information block. And it is what a renowned guy, whose name is Eric Evans, he's author of the Blue Book, which is a seminal book when it comes to domain-driven design. So he's the author, the inventor of domain-driven design. And I urge you to have a look at a talk he delivered in 2009. Just look for, Google for what I've learned 5 years later, what I've learned since the book, Eric Evans, okay? And this phrase is an excerpt from that very session. It really became clear to me in the last couple of years that we need a new building block, and that is a domain event. Okay, so domain event is a compound name, okay? So what's an event? And what's a domain event? And an event is something that has happened in the past. This is the definition that Greg Young gave for events in software, okay? Greg Young is the inventor of CQRS. He actually was inspired by a software engineering principle as stated back in the 80s by Bernard Meyer, who is the inventor of design by contract, okay? And took to another level, and it is, and CQRS it was, okay? So an event is something that has happened in the past. And this definition is really important because it states that an event actually happened. We can't go back in time, okay? We can't, in reality, in the real world, we just can't undo an event, okay? And that's the point. So we could try to compensate something happened, but we can't undo events, okay? And what's a domain event, which is a specific kind of event? A domain event is an event, is something occurring which we are interested in, okay? So when we look at a specific context, a domain, okay, we focus with the help of domain experts in order to get which events are interesting from a domain point of view and which aren't. And that's a domain event, okay? So what event sourcing is all about? Event sourcing is about persisting events instead of entity states. That's the point. And nowadays, events are all around in terms of software development. Think about Event Hub or Event Grid, okay? But back in the day, in 2008, 2009, when DDD practitioners such as me, started talking about events, it was very uncommon to talk about events, okay? Okay, writing persisting occurring events gives us the power to travel in time, okay? Because if we could relate an event to the logic, to the business logic, okay, which is related to that event, we could replay events and have the chance to rebuild objects, system parts, portions, okay, at any given point in time. Recording persisting events means recording an event stream, okay? And what's an event in software terms? Okay, it's an immutable composition Okay, it's immutable. It's happened, and it happened in that very way. So we could have issued an invoice on that date to this customer with this price, taxable amount, total price, taxes, and the like, and whatnot. Okay? So in C# or .NET terms, it means to just write, just define a data structure. Is the font large enough, big enough? Okay, thank you. And what I'm doing here is defining a self-contained data structure, okay? Because an event should be self-describing, okay? It should convey both the meaning, and that's why we're going to use a meaningful name, okay, to go for a meaningful name, and every single information we're going to need in order to have it self-describing. And then it's all about persisting event instances. And what I did here, I am connected to a local Mongo instance and to an Azure hosted Cosmos DB instance. Okay? I'm taking advantage of that Mongo personality provided by Cosmos DB. Okay? And just have a look at an instance of the person registered event. Okay? So and this is it. Every single instance is an occurred event, with every instance providing the needed information to have it end up being self-describing. Okay? Wow. Now, what do I do with those events? Okay? Because as a software developer, as a technician, okay, I am fascinated by the power of the events. Okay? But I have to deliver software to users, and users are more interested in features, such as what's the balance of this job order? Did we actually earn money, or did we actually lose money on that project? Or was that invoice paid, or is it overdue? And do I have to call a customer to say, okay, you owe me money? Okay, that's what users are interested in. So what we need is a way to produce an entity state starting from the events that we stored inside the event stream. Okay, and that's where DDD kicks in. Okay, so why? Because in one of the assets provided by DDD is the aggregate pattern. And the aggregate pattern provides a convenient way to relate a data structure, an entity, in other words, okay, to its underlying logic in terms of business logic, and allows us to, okay, let's have a look at a simple aggregate. I just cloned the GitHub repo, okay? And this is what you're going to have a look at on your machine. So we have two bounded contexts, so subdomains, in other words, which are the registry, okay, and the accountancy. And from a DDD perspective, different contexts do communicate, do interact by means of an API. So each, from a DDD perspective, a bounded context is a microservice. Okay, so you evolve each and every bounded context independently. You deploy them independently, you size them, you scale them, you thingamajig them independently, one from each other. Okay? So, okay, let's just navigate to the model folder. And this is the person aggregate, which is an aggregate, but we'll be talking about technology later, okay? So a person is a party. So it has a registration date and national identification number, VAT number, shipping address, billing address, whatnot address. And being a person, it has a first name and last name as well.
I think you
Oh!
need to shut down WhatsApp right now. Otherwise, it's going to hit the fan in here. I'm just saying.
Yeah.
He's got WhatsApp up.
Forgot to shut it down.
Just saying.
Okay. Okay.
You have the wrong people. I'm just saying.
Okay.
This is very true.
So, in DDD terms, an aggregate should provide logic such as change address, okay, or let's have a look at the company aggregate. A company could change name. So, change name, request the name, effective date, a bit of logic. But what an aggregate does, in order to state, okay, what you asked me to do is viable in terms of business logic, is not to return a red code or the like, but it generates an event instance, okay? And it accumulates the event into a list which stores all uncommitted events, okay? We will talk about persistent a bit later. And what this raise event does is it accumulates the event, the transient event, and it dispatches it to an ad hoc apply event overload, which applies the effects of such an event to the current instance state. That's the point. This means that an aggregate is able to produce an entity state provided someone else gives it every occurred event pertaining that very instance. Okay. The guy providing those events in DDD terms is the repository, okay? Which is another pattern provided by DDD. And what the repository does, it is able to materialize an aggregate instance, even its type and its ID. Okay, I want this issued invoice, outgoing invoice, I want that project. And advanced repositories allows for the passing of datetime as well, okay, in order to materialize an instance with the state it had at any specific point in time. And what I could do with such an instance, I could invoke methods which contains the logic and emits new events, okay? And then asking the repository to save the updated instance. Okay? So this is where events are actually stored inside the event stream. Okay. Time traveling. The first thing I thought when I came across event sourcing 8 years ago actually, was that it allows for the creation of a new breed of business intelligence solution. Because if I were to ask, okay, what we are having a look at is a deploy of the open source projects, okay, fed by real world data, where with real world I mean I actually imported our accountancy database. So these are real data, okay? And what I want to know is how this project ended up with such a balance, okay? And so it started in 2011 and it ended last year, okay? But what I'm doing is, okay, asking the repository to actually materialize 60 aggregate instances, okay? And what I'm doing is firing Google's, Chrome's developer tools, because we're going to talk performance as well, okay? Because replaying events is slower than just fetching a pre-built state. But what we mean with slower, how much slow is slower? Okay, so 60 instances, 60 replays, apply. This is how the balance went a long time, okay? And building those 60 instances actually took, this is the time, the amount of time by which Chrome started receiving information, okay? So those information were produced. Okay, this is HTTP. The difference is pure HTTP time, marshalling time. Okay, so calc 39 divided 60. This is a local deploy, okay? So let's talk performance from an Azure perspective. This is a deploy using MongoDB deployed inside a D1 Linux VM on Azure. So 1 core, 2 gigs, if I remember correctly. Accountancy. So the very same job order, 2011, 2017, monthly. Okay, apply 90. Okay, let's give it another shot. Okay. Connectivity could be a problem. Okay, it's all about how much time do I need to actually download the JSON file. This is an Angular page using chart.js and a chart.js directive, which binds a remote JSON to the graph, to the chart, okay? But this is a viable performance, okay? Without connectivity glitches. And let's do the very same using Cosmos. MERP is an ASP.NET Core application which takes advantage of ASP.NET Core environments. Okay, so it's all about setting environment variable in your app service, web app, or in Visual Studio project properties in order to have it running on Mongo or Cosmos DB, okay? Which is why you'll find multiple app settings JSON specializations, each one providing the configuration parameter for a specific deployment target, okay? So local, development, on-prem, Azure with Mongo, Azure with Cosmos DB. So, okay. So let's do the very same using Cosmos. Now, view your borders, light code. First one, trend analysis. Monthly, developer tools, apply, okay? So comparable performance, but if we weren't to incur in connectivity glitches, MongoDB is faster at reading small data sets, okay? So it requires more data in order to harness Cosmos DB power. That's the point. But this means that .4 milliseconds is the amount of time needed to actually build a Azure border instance at any given point in time, on average. Yep.
Just out of curiosity, are you hosting the MongoDB also in Azure?
Yep. The Linux VM is also on Azure. Actually, I'm connecting to Cosmos using the MongoDB personality. Okay? So, in one case, we're using a proper Mongo installation hosted by an Azure-hosted Linux Ubuntu VM. Okay? Whereas here, we're connecting to Cosmos DB by means of the MongoDB personality. Okay? And this is what I mean with time traveling. Okay? I don't have to store snapshots anymore. Okay? If not for performance reason, okay, I need my objects to be materialized in less than 3-something milliseconds. Okay, so I'm going to store snapshots. Otherwise, events are fine. Okay? Let's talk performance a bit more. Okay. Point is, the vast majority of times, our user only want to know, to be aware of the last known state for an entity. So there's no point in triggering event replay every single time. And this is where CQRS kicks in as an architectural pattern, okay? Because what CQRS tells us is to split our application stacks in different ones. One intended to provide behavior, which means producing events, storing events, and another one which is specialized in reading, okay? What this means is that we can just produce an ad hoc database storing every single last known entity state, and have our application querying that database when it only has to, display this information. Or, please, I'm only interested in current projects, or in projects I am working on behalf of this customer, okay? This is what an RDBMS is really good at doing, okay? Point is, we have to find a way to have the read-only database, the one we run query against, to be consistent with the event store, okay? So that's the flow of a typical and ordinary CQRS ES application. An application sends an intent, a request, to the rule engine, okay? And in the CQRS jargon, those intents are called commands. Commands could be register person, register company, or issue outgoing invoice, register incoming invoice, mark set invoice as overdue, okay? What the system will do, it will process those commands in order to understand whether they are good from a business logic point of view, okay? And should that be the case, it will fire events. And we will end up having different subscriber interested in such events, with each subscriber doing its own thing, such as, updating the read-only database. Okay? Point is, how can we deliver events, messages to subscribers? Okay. We need what, from a design pattern point of view, is called a mediator. And we usually end up implementing a mediator by means of a bus. Okay? So, CQRS ES at a glance. The application layer, the web app or the mobile app, throws commands to the bus, to the mediator, okay? Which in turn will deliver it to the business logic engine, the domain layer, okay? Just to to be consistent in using the domain-driven design jargon, okay, which will validate the command against business logic, produce events, having those events given back to the mediator, which in turn is going to deliver it to interested handlers, such as denormalizer. Denormalizer is a name we give to those handlers that update the read model. Okay. Let's have a look at a simple denormalizer. We will talk about technology later, but okay, this is what a denormalizer actually do. Okay, I am the person denormalizer. I'm interested in this type of events. We could have more complex denormalizers, okay, which with each handlers actually using entity framework to update the read model. This is a code first, a plain code first entity framework model, okay? Just update the name. Okay? Set the administrative contact for this company. So there's no need to update the whole record. We have very specialized database accesses. Okay? And then we have a read stack, which is going to access the read database in order to provide information to the application. And what the simple project does is it just uses the very same code first model to fire query link against the SQL Server database. Okay? Please remember that this database is only going to be is intended to be as read-friendly as possible. So we're talking about denormalization, maybe having tables specialized to support a single view, okay? Taking advantage of the normalization to avoid joins, foreign key updates, and the like, okay? This is not the database storing the truth. It only has to be as consistent as possible with the event store, okay? Okay, how can we deploy such an architecture to Azure? Okay. We could go for an n-tiered deploying strategy, which would mean having a front-end application, web app maybe, talking to the back-end by means of the Azure Service Bus. Okay? Should that be the case, okay, we could consider to split the backend using different containers, ad hoc containers for business logic workflows, denormalizers, and for running queries against the database. Okay? Okay. An n-tiered deployment strategy is all about choosing which kind of container compute strategy to use for the front end and the back end. And we will talk about differences both in terms of features and prices a bit later. Okay? It's not just about choosing, oh, I do like this one and that one. Okay, Docker is cool, so I'm going for an app service in Docker. Docker is cool. Okay, it's about prices as well. It's about fault tolerance. It's about high availability. It's about requirements. Okay. Or we could opt for a full stack deploy strategy. So a single container hosting each and every part of a specific bounded context. Okay? So please bear in mind that we as DDD practitioner naturally thinks in terms of microservices, bounded context. When I say full stack, I mean a container for each bounded context. Okay? Registry, time tracking, invoicing, task management, and whatnot. Each communicating by means of an API. Full stack deploy. Okay, going full stack is cheaper. Okay, because we only have a single container, maybe 2 instances for high availability purposes, okay? But we have fewer moving parts, we have fewer instances, we have fewer instances we're going to be built for, okay? But an n-tiered strategy is a way to have a higher starting cost, but more flexibility in tuning the sizes, okay, of every moving part. So it's very context specific, okay? And let's talk technology and money at last, okay? So when it comes to Azure computing, we do have a lot of feasible choices. Okay, and we shouldn't go for the cooler one. In the backstage, we were talking about hipsterish features. Okay, hipsterish services. Cloud services are perfectly okay. They're very simple to use. Microsoft is using cloud services for some Azure service, but they come with .NET 4.5.1. We could install a newer version of the .NET framework, but that would mean creating a custom setup script, okay, which will make provisioning of those cloud services way slower. And app services are fantastic, okay, very similar to IaaS in deployment terms strategy, okay, but there's no support for third-party software. We can't just install our SMTP server, okay? Or we could go for a VM, which is usually cheaper, okay? But we would end up facing management costs, and we should try to estimate such costs, okay? Docker is super cool, but then we need to go for an orchestrator as well and understand each orchestrator's features and limitations and needings, okay? Or we could use functions for specific features such as file upload, okay? Every time we do have a fire and forget feature, a function could be the most viable the most cost-effective way. Okay. Point is, it's not easy to set a consumption cap for functions. Okay, because the only way to do that is to use to take advantage of the app service environments, which aren't supported in basic and, if I remember correctly, standard pricing plans. Okay, only in premium plans. Okay, or we could go for Service Fabric, but that would mean learning a Service Fabric, the Service Fabric SDK. And so are we going to use the actor model? Okay, that's the point. From a billing perspective, when you look at how much does it cost each and every option, what we get is that the more the platform is doing on our behalf in terms of guaranteeing the service, the more the price goes higher, but the more the management cost becomes lower. Okay? And it is very context specific. Okay? Please bear in mind that, okay, a VM is a cheaper way to have this sort of computing power, but it would be on myself to provide high availability or fault tolerance. So I should at least have this price times 2. Okay? And when we talk Service Fabric, we should bear in mind that the minimum amount of nodes required in order to have Microsoft guaranteeing high availability is 5, and 3 for testing purposes. Okay, so it would be unfair to just compare this price with this one. We should have this one at least times 2 or 3. And we do need a mediator as well, and we do need an event store. Is it going to be Mongo? Is it going to be Cosmos? Is it going to be someone else, something else? Okay, and let's talk bus first. Okay, when it comes to using a bus, my experience is to go for the most feature-packed bus you can afford. Okay? This means, in the .NET space, going for either N-Service Bus or Repos. Okay? With the difference being that N-Service Bus is commercial. You have to pay a license. Okay, and then you could buy support as well, whereas Repos is fully open sourced, and the company developing Repos is trying to build a business model based on support. But the feature set is very, very, very similar. Okay, and that's why we're using Repos. Back in the day, we started using N-Service Bus. Okay, and then we're using Repos, and Repos is the bus used by the project you're going to download. But what both N-Service Bus and Repos do need is they do need a transport protocol. Okay, so think to Repos and N-Service Bus as a fancier API built on top of a transport protocol, such as MSMQ, RabbitMQ, or Azure Service Bus, or Amazon Queues. Okay, so what both N-Service Bus and Repos allow us to do is to program against a fixed feature set, a fixed API, and have it becoming transport protocol agnostic. Which means that what we could end up doing is to, okay, Mongo, okay, when I deploy to Azure, I'm going to use this queue on this service bus instance. Whereas when I'm going to run it locally, I'm going to use this queue. And please note, please bear in mind that Repos could use Azure Service Bus free plans, but in a cumbersome way. So provided that a 1 million per month Service Bus instance only costs €8.5 per month, I strongly recommend you going for a standard pricing tier, okay? Billing tier. And using ASP.NET Core support for environments, this is how we can configure Repos to be able to switch from MSMQ to Azure Service Bus, okay? So I'm basically defining custom environments, okay, on top of the one provided by ASP.NET Core out of the box, which are its development and its production. So what I did, I defined is Azure Cosmos DB, is Azure MongoDB, is on-premises. Reading the environment variable stored by ASP.NET Core. Okay, this variable is, you can specify it in the app service properties by means of the Azure portal, okay? And are we running on premises or within Visual Studio? Okay, then Repos is going to use MSMQ as its transport protocol. Otherwise, it's going to use Azure Service Bus. Okay, so we can program against a fixed feature set and a fixed API, and with a against a feature set which is richer than the one usually provided by the underlying transport protocol. Which means that, okay, if there's one thing I don't like in software programming is polling, okay? And polling, and polling, and polling, and polling, and then polling, and polling again, okay? So what a rich service bus allows us to do is to define workflows in the form of sagas. Okay, I am the outgoing invoice workflow. I am started by an issue invoice command. Point is, when I issue an invoice, I'm well aware of when that very invoice is going to expire, to become overdue, okay? And because I have an issuing date, I do know the payment terms, okay? So I can basically evaluate the overdue date. And what I'm asking to Repos is, okay, please notify me At this point in time, it requires a time span instance. Notify me at this point in time, a message of type outgoing invoice expired, which is a simple data structure, a DTO if you like, just carrying the invoice ID, okay, as a property. And what the bus is going to do is to allow me to subscribe that message. In order to be notified when the invoice got overdue, check whether it was paid, it has been paid, and if that's not the case, to start a mark invoice as overdue. So no polling anymore. Okay? And such a feature is going to be provided independently of the transport protocol. Okay, this is what I mean for a richer feature set provided by a commercial bus. Open source or closed source. Okay. Repos.NET supports MSMQ, RabbitMQ, Azure Service Bus, Amazon Queues, Azure Queues as well. Okay, so it's very likely, it's highly likely, you're going to be able to use Rebus, introduce Rebus in your infrastructure. Okay, and it also requires a storage in order to persist subscriptions and workflow status and timeouts and the like, with supports for MongoDB, Raven, SQL Server, Postgre, I think it is now supported. And starting from Rebus v4, Rebus is net standard compliant, which means you can run it on Linux as well. Net standard 1.6. Okay, configuration back to the future. Lastly, you need a CQRS, an event sourcing supporting framework. Okay, we're in another space. We do have two different frameworks called Memento and Event Store. They're very similar. Still, they're quite different in that an event store is just a library which writes events to a store and reads events from a store. So it lacks an implementation for an aggregate, a repository. Okay, so higher level functionalities, features we're going to actually need. Still, there's a renowned library which is called Common Domain, which provides such features. Okay, whereas Memento is a full stack library. Okay, I'm kind of biased because I am one of the Memento developers, so I'm not going to tell you I think this is better compared to the other. Okay, so let's have a look at both, choose what you like more, and full disclosure, the MERP project uses Memento. That's it. Okay. An interesting feature provided by Memento, it supports alternative timelines. So you can place events on parallel, concurrent timelines, okay, in order to perform simulations. It's a feature which Memento calls speculations, okay? And lastly, let's talk a bit about Event Store, okay? Here it's just about choosing to go for Mongo or Cosmos DB. Point is, Mongo is usually cheaper because Cosmos DB is built on a per collection strategy. So if you need, with every collection costing from 20 euros per month upwards, okay? So if you need geo-redundancy features, if you have a lot of data, okay, Cosmos DB is really recommended, okay? The cheaper event store we can afford is just using VMs to deploy our own Mongo cluster. Please bear in mind that in order to have a cluster in the Mongo space, you need at least 3 nodes, okay? Or we could go for MongoDB cluster instances in the cloud, either on Azure, AWS, Google, okay, so Azure. With one of the viable choices being the Atlas service, which is Mongo Pass offered by MongoDB, the vendor. Okay. Okay, and just a bit of prices. Okay. Now, just to give you some number in order to better evaluate how big an app service or a Cosmos DB or a MongoDB instance I do need. Please bear in mind that importing, the company I work for, the company I founded, is very little. Okay, so we're a dozen employees. Okay, still we have been on the market for 13 and a half years. So we kind of have accumulated quite a lot of data in terms of accountancy data, okay? So importing those data from the SQL Server database, which is used by our ERP system to MERP, generates 14K events, so objects, which with an average event size of half a kilobyte, okay? And with a needing in terms of storage space of 10 megabytes. So, no, peanuts, okay? So every instance is going to work fine, okay? This is because when you start, it's not about penny pinching, but it's just about knowing how much does it cost every single moving part or pillar or service we do need, okay? So, too long to read, the monthly cost for a high available, fault-tolerant CQRS yes installation on Azure spans from 300 euros per month to 500 euros per month. Okay, so let's just try to combine. Okay, I'm going to use an elastic pool. No, I'm going to be built as on a single instance strategy. Please bear in mind that each bounded context is going to have its own database, its own event store, and its own read model as well. Okay. Yeah, this is something we already talked about. We could go for the basic tier, but you know, Okay, I just wanted you to give you a glimpse, a glance of what CQRS ES architecture is and how we can take advantage of Azure in order to deploy such an architecture to Azure. And should you have questions, I'll be available outside the room because I think time run out.
Time is basically up. Yeah, that's fine. It's just this is very hardcore stuff at the end of the day.
Yeah.
And I think just because it's the end of the day, not that this is uninteresting. It's extremely interesting, but our eyes are glazing over. It's been really cool to see this because honestly, this is the kind of things that people talk about, but very few are doing this right. And I just thought it was really fascinating.
Thank you.
Thank you. Thank you for being
Thank
here.
you, guys.
Thanks. So we now we can do questions, but you can leave if you want to, if you need to go, or just stay if you want to hear the questions.
Okay, would you mind repeating the last part?
Or
Because I
did you start with CQRS, or did you make a change to go to that? You started with
no,
something else.
actually we started using ordinary relational databases and design system in terms of entities and states and the like, and we started using CQRS end events in 2009, November 2009.
How do you move from one to the other? How do you start?
With a lot of pain.
Lots of pain.
Okay, it's actually thinking in events is way easier when you get used to, because when you look at the world, okay, the world is a series of occurring events. Okay, I do issue invoices. I do turn on a mobile phone. Okay, yeah, it doesn't come as a surprise that events are getting momentum nowadays just because of IoT. Okay. So that's the point.
That's
the
true.
point.
That's very related.
We
yeah.
understood that we turn up a phone, we shut down a PC. Okay, events occurs and states are just the effect of every occurring event. That's the point. So it's hard to switch. Okay, but when you get used to events, it's way easier. And it's way easier to evolve systems as well, because you discover new events. And it's easier to ask to domain experts for events. Because when you talk with domain events, they just say you, okay, or users, what's your job? What do you do for a living? I do issue invoices, I do register credit notes, I do evaluate a project balance events. So I think it's worth a while. That's it, but that's just my experience. But it took, okay, just to give you a number, it took us, I think, 2 years in order to fully switch. Okay.
Do you have any recommendations for somebody who is in an organization that wants to switch to?
Recommendations. For switching.
Okay.
What do you do?
Hire a consultant, have someone who is already doing CQRS, yes, to help you at least the first time. Okay? And try to squeeze out from him every possible kind of knowledge. Okay? So learn. That's it. You're welcome.
All right. More questions. Go ahead.
Okay. Events have a name. With the name convene the meaning. Okay? When you look at a log, you have to infer what's the meaning of every log entry. You as a human or you as a parser, whereas when you model events, you just model outgoing invoice issued event. And that's it. Because every once in a while, I get tasked, okay, but I could take advantage of SQL Server's temporal databases support and just fire a query and ask SQL Server, okay, what was the invoice state back in blah, 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 point in time? Okay, but point is, you're going to have the state produced by SQL Server, but you're not going to understand why such a state was reached. Okay, you as a human have to infer.
This is true.
That's the point.
That's a good point. Second question.
Is programming-wise, the fact that we are, as far as I understood, is that we need to create like event object for every object we have, or something.
No, you have to define an event for every occurred event, and then you use aggregates, so entities, to both produce and consume those events. When you link an outgoing invoice to a project, what you do is you modify the balance of that project. And from an accountancy perspective, you can't relate a single, you can't relate an invoice to different projects for an amount which is higher than the one specified by the invoice, okay? So a single event, an event is provided by just one entity or aggregate, but it could be consumed by different aggregates in order to have them being capable of producing a state, okay?
All right, you had a question up front?
Yes. When you issue a command with your architecture there, how would you inform the client that you were not allowed to process that command at this moment? I mean, the state could be modified by someone else.
Okay. It
Complicated.
depends.
Can we?
It depends. Callbacks, signalar, it depends. But it's all about a notification system, choosing a notification system.
One more question.
Or firing events. Because if you weren't unable to do something because a business rule would be violated, you can't issue an invoice providing the very same number of an invoice you issued previously. Okay, that's a business event, and you could notify it by means of regular events.
All right.
General CQRS question.
All right.
Like basically any application can be designed using CQRS, like the event sourcing and the materialize view of those things, and like the regular relational or like the custom databases. When should I not use event sourcing? Because I can use any, but when should I not use
Okay.
event sourcing?
When should you not use event sourcing?
Okay. It's
Just to do what?
no. Point is, what strikes me is that the vast majority of time that an article or blog post talks about CQRS, it talks about event sourcing as well. And CQRS can be implemented. You can take advantage of CQRS even without implementing the behavioral part of the system with an event source persisting strategy. In my book, I wrote that sometimes I do use the transaction script pattern to model the behavioral part, which means that I model the behavioral part just in the form of functions. So issue an invoice, okay? Register an invoice. Mark a project as completed with every function adhering to the transaction script pattern, which means they're going to be self-contained. Okay, if you don't need to time travel, if you don't need to know the very reason why something happened, you definitely don't need event sourcing. Okay, and please bear in mind that since an event stream is an append-only storage database, it scales. It scales a lot because it means only appending. It means steering clear of concurrency issues, no racing conditions, no locks, and the like. So you might want to use event sourcing for performance and scalability considerations, and not because you want to time travel, but if you don't have extreme scalability issues, and if you don't have the need to time travel, there's no point in using event sourcing.
I apologize, I meant CQRS, but I meant event sourcing, that when should you not use event sourcing? I stated wrong and I asked the question, should you not use CQRS? You have answered that.
You should always use CQRS.
That's right.
Point is,
Well-
a single unit of code should either perform, provide behavior, or retrieve information. It's because following such a strategy, which is a common query separation principle, which was stated back in the 80s by Bertrand Meyer. Okay, what Greg Young did was to take a principle which was stated on a function basis and got to a application stack basis. Okay, but there are always good reasons to model function as either being able to do something or retrieve information, because they're going to be simpler to either write and test. That's one. Think to it as an extreme way to apply the single responsibility principle. That's it.
Basically, the expression CRUD is not adhering to the single responsibility principle.
Indeed. Totally agree. 100% agree.
Right.
And
All right.
we are kind of grew up thinking in terms of CRUD.
Yeah, we have. That's what we learned in school.
Type of data set,
That's what we
data
learned.
grids.
Yeah, you need to have all these things on the same, because it's you have to do all the things, right? All of the create, read, update, and delete. When
But
there's a-
we
when-
don't
when there- when there-
delete
when-
invoices.
When there is an enumeration and an and in there, you know you're not doing single responsibility.
Point is, in the
Alright.
real world, we don't delete invoices. We do either issue or register credit notes. But we don't delete things
Right.
in the real world.
So I think we need to call it. This is it. Thank you
I
guys
think
for
so.
being with us.
Thank you, guys.
Thank you. Thanks.